Hello everyone, this video is a presentation of homework 2 and problem number 2. First, we are given the probability x1 equal to 0, which equals to 0.2, and the probability that x1 equal to 1 equals to 0.8. Then we are given 4 kind of probabilities in 4 different situations, which indicates a relationship between an event and the event next to it. First, let's see the question number A. We need to find the probability of x2 equals to 1. And if we are going to find this probability, we need to know 2 probabilities, which is first, the probability x2 equals to 0 when x1 equals to 0, and the probability x2 equals to 0 when x1 equals to 1, and the probability of x2 equals to 1 equals to this one plus this one. First, the probability of x2 equals to 0 and when x1 equals to 0 equals to the probability x1 equals to 0 multiply the probability x2 equals to 0 and when x1 equals to 0, which equals to 0.2 multiply 0.6 equals to 0.12. Then the probability of x2 equals to 0 when x1 equals to 1 equals to probability of x1 equals to 1 multiply the probability x2 equals to 0 when x1 equals to 1, which equals to 0.8 multiply 0.3 equals to 0.24. Yes, that's right. So now we can get the probability of x2 equals to 1, which equals to the probability x2 equals to 0 when x1 equals to 0 plus the probability x2 equals to 0 when x1 equals to 1 equals to 0.36. So this 0.36, let's see, 0.36, right? Now it's the question number B. We need to, we need to find the probability of x3 equals to 1. So if we like to find the probability x3 equals to 1, we need to figure out first that these 2 probability, which is probability x2 equals to 1 and the probability x2 equals to 0. We've got this probability here, 0.36 equal to 0.36. Then we need to get this one. So this one equals to x2 equals to 0, which equals to, let's see, it's equals to the probability x2 equals to 0 when x1 equals to 0 plus x2 equals to 0 when x1 equals to 1, which equals to 0.2 multiply 0.6 plus 0.8 multiply 0.3, and this equals to 0.36. So the probability x3 equals to 1 equals to the probability x3 equals to 1 when x2 equals to 0 plus the probability x3 equals to 1 when x2 equals to 1, which equals to 0.36 multiply 0.4 plus 0.64 multiply 0.7, which equals to 0.592. So this is question number B. Then we're going ahead. We're going to problem number C. Yes. Now in problem number C, we need to find the probability of x1 equals to 0 when x3 equals to 1. So first we need to figure out that the probability x1 equals to 0 when x3 equals to 1 equals to the probability x1 equals to 0, x3 equals to 1 over the probability x3 equals to 1. This is the definition of the conditional probability, and then this equals to, let's see, this equals to probability x3 equals to 1, x1 equals to 0 multiply the probability x1 equals to 0. This is the reverse use of the definition of the conditional probability, and then over the probability x3 equals to 1. So in this function, we know this probability, this one, and this probability. So the only one we need to get is this. So then let's go on. The probability x3 equals to 1 when x1 equals to 0 equals to 0.4 multiply 0.7 plus 0.6 multiply 0.4. So let's see, this equals to 0.52. Is it correct? Yes, it's 0.52. That's all right. So now we can get the probability that x1 equals to 0 when x3 equals to 1, which equals to 0.52 multiply 0.2 over which we got x3 equals to 1. The probability of x3 equals to 1 equals to is 0.592. This equals to, let's see, we should calculate this like around 0.176, around this, right? Then let's go on. Then is the last question, question number D. We need to find which one. Let's see, find this limit n close to infinite, the probability xn equals to 0. We need to get this one. So let's use some matrix problem. We can assume that the probability, the distribution situation of the probability when xn according to xn just equal to the probability distribution situation when xn equals to xn plus 1. So these two should be just the same as each other. Like, we can assume that the probability of the xn should be distributed like this: x and 1 minus x. It should plus a matrix like this one. So it will equal to the probability distribution of the events next to it, but the probability distribution should be just as same as each other. So we have this equation. From this equation we get this one. Which we can get we should get a equals to 3/7 and 1 minus a equals to 4/7. So we have the probability when n close to infinite, the limit should be xn equals to 0. This limit should be just like a, which equals to 3/7. So this is the solution of the homework 2, problem number 2.